Well, the challenge is before us now that we're working on new technology and the chemistries that are going to be using products that have had some bad images in the past in terms of drift issues, the dicamba or products of that nature. So, the chemistries are being created because of the issues that have developed in the weed resistance market, not being able to control the weeds. Now, from my perspective in application, I consider that there's been some factors that have led to that weed resistance that are application issues, and that's where I'm interested in pursuing this. We need to get growers or commercial applicators in a frame of mind that if they're going to apply these products, they need to select and use a spray nozzle correctly so that they don't create the drift potential that is possible in some of our older nozzle technologies. And if we do move to these newer technologies that are definitely designed to reduce the spray drift, the challenge is they might not get the adequate coverage on the canopy of that crop, that weed, to actually control the weed. So we're working in our research programs to evaluate how to best suggest using those nozzles to accomplish both good weed control and at the same time minimizing spray drift. Applicators have had a real easy way of going about applying products the last few years with, put the Roundup in the tank and go to the field. Now when we start talking about some tank mix combinations, some pre-mixed materials that are going to have some different compounds, different chemistries, they're going to have to start focusing on some of the specifics, factors that are influencing that application process, and speed of travel in the field, height of boom above the target, pressure that they're going to use, the gallons per acre, the application volume they're going to use. And as we move more and more further into advancements in technology with the spray equipment, it just seems that the technology has driven us into bigger spray machines, higher speed spray machines. I understand the purpose. We got, and this program's not going to be any different. We've got a very critical time when we have to put that herbicide material out to best control the weeds. I think that's where we've gotten in trouble in the past. We've used our glyphosate applications as a mask over some scenarios that we probably shouldn't be in. The weeds got too big. So the companies are, they're under pressure, pardon the pun on that word, to get that crop sprayed in a timely fashion so the weeds are controlled when they're at the size they're going to control, and that's imperative, and that they have a big machine and go fast. So you've got to kind of work against that a little bit to impress upon them. It's still important to do a good job so they can control that weed, and then in the years in the future that won't be an issue like we're facing today with the resistant weed variety situations that we have out there. Obviously the number one goal of that application is to have good weed control, and right along beside that you have to have good drift management practices so that you don't cause some concerns due to the off-target movement. And if we add into that, whether it's the grower or the commercial applicator that's interested in maximum productivity, a lot of acres to cover, so many hours to do it, they get up against environmental considerations that influence their daily activities, whether it's a rainstorm that goes through or excessive wind that prevents them from doing the application. They get behind the 8 ball. So it's a balancing act to get good efficacy, minimize drift, and do it in a productive manner.